Hi, everybody. It is time for some midterm review. This is for Science 10. And I've been working on Brightspace, making it all pretty. And I thought it was time to do some of these 7-column charts. I know there's not a lot of examples out there, so we're going to try. If you go to the chemistry part where it says midterm review, you can get a copy of this. Okay, you can print it yourself or just go, hey, Joanne, I'd like a copy of it. Or maybe you want to just copy it on a piece loosely. Whatever works for you. Doesn't matter to me. We're going to go through this and maybe you're going to pick up some tips on how to do this easy. Because without having seen this before, these things look real weird and really complicated. Number one tip. The number of protons and the atomic number are always the same. Always, always, always. So this one and this one are always matchy-matchy. And the other thing I should tell you is I don't do it one line at a time. I do it kind of like by columns. Again, I don't want to do more work than I have to. So if I know that the atomic number and the number of protons is, hold on. Sorry, I just had a moment. This column and this column, there, are always the same. So if I have a number in one of the columns, I'm going to write it in the other column without even thinking. 3 goes there. Oh, and 1 goes here. Oh, nothing there. Oh, 54 goes here. Oh, nothing. I don't know why today I decided I needed a ruler, but this is also making me happier because it's helping me focus. Nothing. Nope. 8 and 6. 74. 8. And a look. I got a whole bunch of answers without having to try really hard. Next thing I'm going to do is I'm going to deal with the name and the symbol. So truthfully, to identify an element, you need one of these. You need either the name, the number of protons, the atomic number, or the symbol. Any of those 4 things will uniquely identify an element. So this one says it's lithium, and there it is over there. So I'm going to do my symbol, lithium. Now this is element number 21. I'm going to say, oh, there it is, scandium. Thanks, it's going to have to go. DIUM. And while I'm at it, I'm going to put SC over here. Okay, aluminum. Aluminum is, there it is, number 13. So now I know this one, 13, and AL, not AI. Whoops, sorry, my bad. There we go. Okay, I'm kind of pleased with myself right now that I colored these in because it's really making it obvious that those 2 need to be the same, and I'm not going to forget it. So now I want 54. So atomic number 54 or 54 protons, whatever. Where's 54? Oh, there it is. It's xenon. Oh, and not to mention the symbol Xe sitting over there. So you actually have too much information on this one. Platinum. There it is. Oh yeah. Nope. You can still see me on screen. That's 78, and that's 78, and this is PT. And I think at this point, y'all should turn off the camera, pause your video, not the camera, pause the video, and fill in the rest of these 4 columns. So by the time you turn the camera back on, you should have the name, the number of protons, the atomic number, and the symbols all filled in. Please do it. As always, if you just sit there and watch me, It's a really passive thing and it's not going to stick when you got to do it by yourself on the exam. Okay, here we go. Number 33. There it is, arsenic. Arsenic 33. Yes, over there. Carbon. I know the symbol C. And I'm hoping you do by now too. PB 82. Where'd it go? There it is. It's lead. And everything else is good. Gold. I know my symbol is AU. I have, whoops, have that memorized. And if I look on my periodic table, see now, from here. There it is. There's gold. It is number 79. So 79 goes there, across, and 79 goes there. All right, so we got nickel ion. I'm gonna leave this one because it's got the word ion in it, which means my number of electrons is not gonna match up. So I'll worry about that when I have electrons, but I can. I'm gonna put Ni, and I'm gonna put a little star here to remind myself to double check because I know it's nickel, but I know there's something up there and I just don't know what, or rather, I don't want to figure out what it is right now. We got, oh, here it is. Our friend carbon. Yeah, if you write carbon, I'm going to give you half marks. We need to add the word ion because it's got a charge. All right, tungsten. Ooh, has the memory. Tungsten's one of those weird ones. Tungsten, tungsten, tungsten. There it is. It's number 74. It's got a W as a symbol. I think it's a German word. Wolfram. So what am I trying to remember? I think it's a symbol. Oh, yep. So that's a W. And now, oh, okay, we got oxygen. I said, oh, and there it is. All right, so. I would not be mad at you if you wrote oxide, because that's the scientific chemical name for an O-2, but oxygen ion is fine too. And yeah, I'm not sure what's going on down there. So I'm just gonna ignore it for now. Because like I promised you, I'm doing all the easy stuff first. So for me, the name, protons, atomic mass, and symbol are the simple ones. Now we have to do some work. I'm gonna be lazy. I'm gonna do electrons next. So if you remember, your protons are your positive charge. Electrons are your negatives. So added up, those two have to equal the charge on either the atom or the ion. Okay. So if I take a look at lithium, because there's not the word ion here, so I want you to pay attention to, see, all these to here are just the element. So that means it's neutral. So nobody writes it. Oh, I guess it wouldn't go there. You could have little zeros there, but it looks weird. Actually, I can erase that. Somebody's going to look at the answer and go, what was she doing? But all of these ones, until it says ion, I know my number of protons has to equal my number of electrons. Has to, because the number of positives has to bounce the number of negatives. So that means 3. Oh, I already got 21, so 13, 4. Finish it up. I don't think you have to pause the video. I'll just keep chatting. 6, 82, 79, and then we get to nickel ion. Okay, so these ones, I got the word ion in there. I got to pay attention now. Let's see. So this is 28 pluses. and 27 negatives. And there is nothing wrong with you writing that. You don't require to because I don't care, but it'll help me. So when I add these together, I get a +1. So that fits with the ion. And then I'm going to tootle over here to the nickel. And remember, I put that star there because I knew it had some kind of a charge on it. All right, now we've got the carbon ion. Now this one works the other way. Over here, it's telling me it's a +4 ion. So it's got 6 pluses and it needs some negatives. I'll talk about 2 different ways you can do this. First of all, this is what I have to have left over. So if I have 6 pluses and I put 2 negatives, then there's my +4. Okay. The other way you can look at it, try and think what the other way was, because that way worked really well. Oh, if this is a +4, this is the cheat. If you subtract 4 from your protons, you're always going to get the number of electrons. So if you do the opposite of whatever that charge is, it'll work every single time. Still, that being said, I would probably always double check at this point. So +6 minus 2, that gives me a +4. Now tungsten, oh, wait a minute, being sneaky. It doesn't say anything about it being an ion. So 74, right? Unless it has the word ion, or it's, yeah, it would have to have the word ion. I was going to try and make it into a tungstenide, but that doesn't work. That only works on the ones that become negatives. Anyway, there we go, tungsten. Now oxygen ion, it's telling me over here it's a -2. So these are my pluses, these are my negatives. I have to have 2 more negatives than I do pluses. So that becomes 10. And my cheat, if this says -2, I'm going to add 2 to this, and we're good. And I still really don't know what's going on with that last one, so I'm just going to choose to ignore it. But look, we've got almost all of it figured out. And so far, it hasn't been too hard. The last part, the atomic mass and the neutrons, are where we have to do a little bit of thinking. Because sometimes the answer is, sometimes you add, sometimes you subtract. You just got to keep straight. So what you need to know is the number of protons plus neutrons is equal to the atomic, oopsies, mass. I think I'm going to be lazy again. I'm going to just, hold on, I lost my ruler. There we go. Okay, so I have protons, I have neutrons. So you don't have to do this, but just so you guys, you lovely students, see where this is coming from. I'm going to take this one, and I'm going to write it really tiny. So that's where the 8 is coming from, protons plus neutrons. Now, I don't have that. Oh, look, here we go again. I got protons and I got neutrons. So I'm going to go 13 plus 14, and that's going to give me 27. And then I'm deciding that that looks messy, and I'm not going to do that anymore. But I'm just going to go down my list here now. Oh, here we go. Oh, that's too much like work. I'm going to take 78 and I'm going to add 117, 8, 195. Okay, pause the video. I want you to complete anything on here where you've got these 2 columns. If you don't have those 2 columns, just leave it blank for now. So stop the video, please. I'm humming in my head when I'm doing this because I'm assuming that you stopped the video. All right, where are we? Nope. So basically, I'm looking where I have my number of neutrons. So I got 6 here, 6 there. It's going to give me 12. Nope, don't care. I'll deal with that in a minute. I've got 79 protons and 118 neutrons. So 79 plus 118 is 197. I got 28 and 31. It's 59. Nope, nope. That's 74 plus, oh really? That's like 184. I'm embarrassed I used my calculator. And nope, nope, nope. Okay, still don't know what's going on that last one, so I'm still ignoring it. That's not bad. Look, we're down to one column that's not finished. And this is just my personal choice. I believe it's faster if I do it column by column, because then I'm only having to remember one rule at a time. If I try and go across, it's like, which rule do I do now? Am I adding? Are these the same? I don't like that. I would rather just use one rule. So now this last part is kind of the opposite. We know the atomic mass. We know there's 45 things in the nucleus. So what's in our nucleus? Our protons and neutrons. So if we take 45 minus 21, it's going to give us our number of neutrons. And that should, I'm going to write 45 minus 21, and that should give us 24. And don't judge me, it's the end of the day. I'm double checking. Well, surprising, it's 24. So if you have the mass, let me write that at the top. Atomic mass minus the protons, it's going to be neutrons. Oh, here we go. So it's going to be 131 minus 54. Nope, not doing that. Not in my head. That's 77. Okay, done. Not sure what I pointed to last night. It should be this column all the time. So 75 minus 33. Oh, you probably knew that answer faster than I did. That should be 42. Once again, turn off the video and you should be able to finish everything up, but this very last one, we'll figure it out. All right, I'm going to say you're back. So we're still subtracting. Our atomic mass minus our protons is going to give us our neutrons. So 207 minus 82 is 125. Got it. Now we got to be careful here. It's 8 minus 6. Remember, it's always minus the protons. Over here, I may even have accidentally done it. If I screwed up and pointed to the electrons, that was bad, but it didn't matter because it was all matchy-matchy because they were neutral. Got to make sure. 8 minus 6 is 2. Done. And now we've got 16 things in the middle, so 16 for a mass, and we have 8 protons. That's going to leave us 8 neutrons. Okay. Time to figure out what's going on here. Actually, it's messed up. Because according to this, I have 22 things in the nucleus, and 40 of them are neutrons. That can't happen. That's like saying, hey, I got 22 students and 40 are male. So this one's just messed up. So we'll just cross it off. Sorry, so sorry. Oop, done. Okay, what I would suggest is you turn off the video. Try this one on your own. I can see it's got a lot more ions going on here, so I'm not really sure what it's happening. Just a minute. Okay, I'm back. Sorry, a little disrupting there. As I said, try it. I just don't want to make a second video because then it's just more work to post. So here we go. I'm going to assume that you know what's going on. I'm going to take exactly the same process. So number 1, I'm going to look at my number of protons and my atomic number. And yes, if you notice, the order of my columns here and the order of my columns down there are not the same. I do that on purpose. I don't want you to memorize that the first column and the third column are always the same. No, I want you to think. But I am going to color code again. I like that. So there's my protons, and here's my atomic number. So I'm going to start with easy, matchy, matchy. 37. So like by definition, the atomic number is number of protons. So if I have one, I have the other. 2. Nope, I don't have either of them, so I'll just skip that for now. 10 and 7. 1. Okay, done. Look at that. Super easy. Oh, I forgot something. I'm going to go up here. Back to this one for a second. When you are done, I strongly suggest, because I'm also a paranoid scientist, not only a paranoid mathematician, take your finger and just make sure as you go down that it's matchy-matchy all the way down. It's easy marks, right? So let's not waste that. All right. So done. Now we need to pull out the periodic table and let's find all our symbols. So I got zinc, Zn. You should probably know these. I'm not going to worry about the fact it's an ion. I'm going to double check that when I do the electron part. All right, and I'm not even going to insult either of us by looking that up on the periodic table. We all know it's nitrogen. I don't know if it's an ion right now. Figure that out in a little bit. Fluorine, the symbol is F. It's an ion. I'll deal with that later. Calcium. You guys know these. Calcium. And I'm going to add the word ion right away because it's right there. B, in case you're not sure, because we don't talk about boron very often. There it is. And see, it's got the +3, so I'm going to throw the word ion in right away. We got platinum. Where's platinum? Platinum, Pt. And again, I know there's going to be an ion coming. One sec. Sorry. It's 10:04 in the afternoon and people are like going home and want to say goodbye. And then they, Anyway, where are we? We did platinum. Now we've got P. So it tells me it's number 15, sorry, phosphorus. And I need to squish ion in there because there's a charge. Now, sodium. There it is, number 11. You could also be using the other chart that's got ions on it. I don't know if that makes it any easier. Okay, I got the periodic table sitting here and I found it first when I was doing this. So it's Na, Br. I guess it's a little late to say, hey, turn it off, fill in all those columns. Bromine, ion. And if you want to call this bromide and you want to call this phosphide, that's okay. These guys, because they're positive ions, the names wouldn't change. You just need to remember to have the word ion after it. Neon is 10, Ne. N is just plain nitrogen. Oh, we had nitrogen up there too. All right, we got sulfur, we got hydrogen, and we got hydrogen. So those were mostly based on I had either the name or the symbol, and you can consult your periodic table. But hopefully some of these you've got memorized by now, some of the more common ones. Okay. I guess let's deal with electrons now. So protons are my positives, electrons are my negatives. So on this one, I have 30 positives and 32 electrons. Whoops. I'm saying whoops because I know zinc, whoopsies, forms, all right. This should have been 28. That was my typo, putting that in there. You didn't know that, but I'm fixing it so it's actually chemically correct. And this would give me a +2. Based on the 32 that was incorrectly there, if you put -2, I would give you 100% because the mistake's mine, not yours. Okay, nitrogen. No charge. So that means my protons, which are my pluses, and my electrons, which are my negatives, are matchy-matchy. Fluorine. Eek. There's another mistake. I'm gonna fix the original sheet so that the assignment, when you look at it, is okay. So 9 pluses, 10 negatives, and that means it's going to be a -1 here. I'm sorry, I feel guilty. Let's see how we did on this one. Oh, this one looks okay. I got 20 pluses. Now I need to find out how many negatives. So there's 2 ways. You can just think it out. I have to have 2 more pluses than I do negatives, so that means it should be 18. Or you can say if it's a +2 ion, I'm going to go here and I'm going to subtract 2 and I will get my number of electrons. Either way, it's going to work out for you. Now we got boron +3. So if I have 5 here, I'm going to use my cheat rule. I'm going to subtract 3. So 5 minus 3 is 2. Whoops, goes up here. All right. Now let's see, platinum ion. I've got 78 pluses and 74 negatives, which is a difference of 4. And there's 4 more pluses, so we'll put +4 there. All right, phosphorus. So I've got 15 pluses. And for my negatives, I need 3 more. So 15. And if I need more negatives, that means it's going to go up by 3. Or my favorite cheat, if this is -3, I add 3, and boop, there's 18. You can do that as a double check, whichever one makes you happiest. All right, sodium. It's got 11 pluses. Oopsies. Huh. Again, we're missing a bit of information. And so I'm just going to go on my chart and I'm going to say, so sodium ion, I know it's in this family, the alkali metals, and these guys are all +1. Or you can look on your chart, the ion chart. So sodium ion is +1, which means this needs to be 10. And just forgive me for a second. I'm just going to star those ones so I can fix the original sheet. All right. Bromine ion. Oh, I do not know the missed number of protons on that one. Bromine. Oh, there it is. Sorry. It's got 35. 35 protons. And I'm going to cheat, go right here, right away, because those 2 are matchy-matchy. And if I need a -1, so these are my pluses, I'll need 36 minuses. And that'll work. Neon, no charge, so we're all good. Nitrogen, okay, nitrogen -3. So I need 3 more electrons. So my pluses, these are my minuses, and it's going to be 10. Now this one says it's a sulfur ion, plus, minus. I've got 2 more, move my screen, 2 more negatives. So this is going to be S -2. All right, then some weird stuff's going on with hydrogen down here. Let's see what's happening. It says it's an ion. So I've got 1 plus, 0 electron. Yeah, you can have 0 electrons. Hydrogen is a very small molecule. So minus, excuse me. So +1. And then this one is just plain old hydrogen. So 1 plus, 1 minus, and that equals 0 charge. So we're golden. You don't need these pluses here, and these negatives over here. I've just been throwing them in because for me, it's easier to explain it to you that way. And it's easier for me to figure out. So if you want to put those in there, that's completely fine. Don't care. All right. So now the last part, we got to deal with the atomic mass. So remember, there's kind of 2 things you got to remember. I'll maybe write them down here. So your atomic mass equals the number of protons plus neutrons. Or, honestly, if we just subtract the protons from both sides, we can say atomic mass minus my protons is equal to the neutrons. Or you could have subtracted the neutrons and got protons. But normally you know what the protons are. Okay. So, oh, here we go. I'm going to start it with this one. So if I know my atomic mass and I know my protons, I can do neutrons, right? It's atomic mass minus protons is that. So 65, I'll throw it in here, minus 30 is equal to 35. There we go. And I'm just going to cheat. I'm going to go here. So this is going to, I'm going to do all the same type of questions, just like the top. And then I'll go back and finish the other ones. So 19 minus 9 is 10. 42 minus 20 is 22. Nope, I don't have. Just going to do all the ones with the atomic mass. Well, 32 minus 15. 32 minus 15 is 17. Yeah, I should have known that. 23 minus 11. So my mass minus my protons is 12. My mass is 20. So there's 20 things in the nucleus. 10 of them happen to be protons. The remaining 10 are my neutrons. Okay, has that hydrogen on it? Looks weird. So I've got one thing in the nucleus. It's a proton. 1 minus 1 is 0. So there's no neutrons. And that's okay. Oh, cool. So this form of hydrogen. So these 2 guys are an isotope. There's 2 ways to explain isotopes. They have different masses, and right away we're going to find out they have different number of neutrons. But they're still hydrogen because they have 1 proton. So this has got 3 things in the nucleus. One of them's a proton, so the remaining 2 are neutrons. Okay, we're almost there. What happened here? Uh-oh. I'm sensing I never gave this assignment to students and I never did an answer key because there's another problem there. We'll fix it. We'll fix that in a minute. Let's do this. So our other rule is the atomic mass is equal to the protons plus the neutrons. So we should be able to fill in all of these now. So my protons is 7, my neutrons is 8. So I'm going to squish it in there. 15. All right, going down to boron. My protons is 5, plus my neutrons is 7, and that's going to be 12. And then we get to platinum. Okay, so the problem is we should have either this or this. They can't both be blank because that's not going to work. So I'm going to make a decision, and I can do this. And I'm going to make that, we're going to say the atomic mass is 198. So my worksheet, I can do that. So now I'm going to go 198 minus 78 should be 120. So let me put a little star there for that part too. I'll fix that later. Filled. Here we go. Maybe. Yep. Okay. So protons 35 plus 45. That should be 80. Yeah. That's going to be 80 for our mass. Done. Okay. We got nitrogen, we got 7 protons, we got 7 neutrons. That's going to give me 14. And there. I got 16 protons, I got 16 neutrons. That's going to give me 32. And in case you're seeing a bit of a pattern there, with atoms that have a low number of protons, the number of neutrons is often the same. So like for nitrogen, it's 7 and 7. For sulfur, it's 16 and 16. Same thing with neon. But as the elements get bigger and bigger, you tend to get more and more neutrons in there because the neutrons kind of act as a nuclear glue to keep all those protons together. So the more protons we have, the more glue we've got to stick in there so that the nucleus doesn't explode, because those protons will have positive charges. So they're going to try and push each other apart. Oops. And ta-da, there's the end of our chart. And check, matchy. All right. Woo, ta-da, we are done. And thank you for watching this video. I hope that cleared it up. I hope you also paused the video when I asked you to. If you need some help, come see me. And for the 6th time, I'm just going to apologize about the mistakes there. Have a lovely day. Take care.